In 1801, Thomas Young let light pass through two thin slits, and on the wall behind he saw stripes. Bright, dark, bright, dark. Light, he realized, had to be a wave. 2 centuries later, physicists tried the very same thing, but firing one particle at a time. A single photon, a single electron. What they found erased the line between wave and particle, and led Richard Feynman to call it the only true mystery of quantum mechanics. Let's run it. Here is what makes it impossible. First, wave-particle duality. A quantum object is neither a wave nor a tiny ball, but something that behaves as both. Second, superposition. Until you measure it, the particle takes every available path at once, described only by a wave of probability. And third, measurement. The instant you detect which slit it went through, that wave of possibilities collapses, and the magic disappears. 3 ideas. 1 unanswered question. What exactly counts as looking? We fire photons at the barrier, one at a time. Watch the screen. Each photon arrives as a single bright dot, a particle landing in one spot. Random, scattered. But keep watching. As the dots pile up, hundreds, then thousands, something impossible takes shape. Bright bands and dark bands. An interference pattern, the signature you only get when a wave passes through both slits at once and overlaps with itself. But we sent them one at a time. Each lonely photon, with nothing else around it, somehow travels through both slits and interferes with itself. So which slit does each photon really take? Let's just look. We place a detector at the slits to catch the path of every particle. Now, watch what happens to the pattern. The fringes are gone. The instant we know which slit each photon goes through, the interference vanishes, leaving a single dull smear. We applied no force. We blocked nothing. Merely knowing the path destroyed it. Stop looking, and the stripes return. The universe behaves differently when it is being watched, and nobody fully understands why. Maybe this is just some quirk of light. So let's try electrons, pieces of solid matter, the very stuff you are made of. Same barrier, same screen, and the fringes come right back. Matter interferes with itself, exactly like light. We can even tune the apparatus, widen the gap between the slits, and the bands crowd together, narrow it, and they spread apart, precisely as the wave equations predict. This is no trick of photons. Everything at its core is a wave of possibilities. Now, compare the world you know. Roll classical balls through the same 2 slits, and they do the obvious thing, through one slit or the other, piling into 2 simple bands. No stripes, no mystery. That is the world our intuition was built for. The strangeness only switches on when things get small enough to be quantum, which deep down is always. We just rarely look that closely. This was SimSciences. One paper, one simulation, one impossible idea turned into something you can run yourself. The link is on screen. Fire your own photons, place the detector, and watch reality change the moment you look. Subscribe, and we'll keep turning the laws of nature into things you can reach out and touch.